Hi everyone, in this video we are going to discuss about the equation of a straight line in the point slope form. That means if we are provided with the coordinates of a point on a straight line and the slope of the straight line, then how we are going to find out the equation of that straight line, right? So that is the task here. Now let's suppose we have a straight line like this, the straight line L, which is the blue color line, and there is a point on that straight line which is point A, and its coordinates have been provided as x sub 1 comma y sub 1. And then let's take a moving point P on the straight line and its coordinates are variable x comma y. And also let's assume that the angle that this straight line makes with the positive y axis, let's assume that angle is theta degree, and then we have been provided the value of theta or maybe the value of m, which is the tangent of theta, right? So sometimes in a question you may be provided with the value of theta, or sometimes in another question you may be provided with the value of the slope itself, which is m, right? So in any case, whether you are provided with the theta or the slope itself, we can easily calculate the slope, right? So if you are provided with the theta, then slope will be tangent of theta, or if you are directly provided with the value of slope, then it's even easier, right? So now what I'm going to do, I'm going to draw a quick little triangle here and then we'll go from there. So let me first draw the triangle. So what I have done, I have drawn a line segment AQ which is parallel to the x-axis and another line segment PQ which is parallel to the y-axis. So that means the angle AQP or PQA, that angle would be a right angle. So this will be a right angle. That means our little triangle APQ, that is a right triangle. That's a right angle triangle, right? Now because AQ is parallel to the x-axis, then the angle PAQ, this angle PAQ right here, that angle will also be equal to theta, because if you think about the two parallel lines which are AQ and the x-axis, for those two parallel lines, if we assume that the straight line L is a transversal, then those two angles will be corresponding angles, meaning our original angle right here, the angle between the straight line and the x-axis, and the angle PAQ, those two angles will be corresponding angles, so they will be equal then. Now if that is the case, then what is the slope of our line segment AP? So now I am going to say that slope of our line segment AP, and if we assume that that is equal to m, that will be equal to tangent of theta, and that will be equal to PQ divided by AQ. That's the rise over run, PQ divided by AQ. Now what are the coordinates of the point Q? Let's try to figure that out. So the coordinates of point Q would be like this. The x coordinate of Q would be same as the x coordinate of P, because they both are on the same vertical line. So that would be x, because that's the x coordinate of P, and Q will also have the same x coordinate because both P and Q on the same vertical line. And then what would be the y coordinate of Q? Well, the y coordinate of Q will be same as the y coordinate of A, because they both on the same horizontal line. The point A and Q, they're on the same horizontal line, so the y coordinate of Q will be same as the y coordinate of A, and that is nothing but y sub 1. So those are the coordinates of Q, right? Now what I'm going to do in this equation, I'm going to substitute some values here. So what would be PQ, the distance PQ? Well, the distance PQ would be the difference in the y coordinates of P and Q. So that would be the y coordinate of P, which is y, minus the y coordinate of Q, which is y sub 1, divided by what is AQ? Well, AQ is the distance which would be the difference between the x coordinate of Q and A. So what would be the x coordinate of Q? Well, that is x. And what is the x coordinate of A? That is x sub 1. So from here, what do we get then? Well, from here we can say, okay, if we multiply both sides by x minus x sub 1, then it will become like this. So we can say, okay, m times x minus x sub 1 is equal to y minus y sub 1. And from here, if we just write it the other way, we can say, okay, then y minus y sub 1 is equal to m times x minus x sub 1, and that is the equation of this straight line. So this is the point slope form of the equation of this straight line. And in this equation, as you can see, that we have two pieces of information known to us. One is the slope, which is that m right there. The slope of this straight line is known to us, meaning it has been provided to us. And also the coordinates of the point A, which are x sub 1 and y sub 1, they also have been provided to us. And using those known values, now we are able to form the equation of this straight line, which turns out to be y minus y sub 1 is equal to m times x minus x sub 1. Now let's take an example. say suppose the slope has been provided as 2 and the coordinates of a point on the straight line have been provided as, let's say, 5, 6. That is the information provided to us, and we have to find the equation of the straight line. Well, not a big deal. We are going to use the same equation. Equation of the straight line would be y minus y sub 1 is equal to m times x minus x sub 1. Now what is x sub 1? Well, this is actually our x sub 1 right there, the value 5, positive 5. And what is y sub 1? Y sub 1 is the positive 6. Those are the two coordinates given to us. And of course we have been provided the value of the slope also, the value of m. So then can we write it like this? From here can we say that okay, then y minus what is y sub 1, that is positive 6, is equal to m. What is m? M is actually positive 2 times x minus what is x sub 1? X sub 1 is positive 5. So can we write it like this then? All we have done here is we have replaced the values of y sub 1, m and x sub 1, meaning we have substituted the values of x sub 1, y sub 1 and m, right? Now let's just simplify a little bit. From here it's pretty easy. So you can say y minus 6 would be equal to 2 times x minus 10, and from here can we write it like this? Let's bring everything to one side, so that would be 2 times x minus y and then minus 10 plus 6, all of that equal to 0. And from here we can say okay, then 2 times x minus y and minus 4 is equal to 0, and that is the equation of this straight line. And of course we can represent it in other formats also. Maybe let's keep the x and y on one side, so you can say 2 times x minus y is equal to 4. That is also another format of the same straight lines equation. And from here also we can say okay, how about keeping y only on the one side? So from here can we write it like this, that y is equal to 2 times x minus 4. So all three of them are valid equations and they all represent the same straight line. It's just three different look and feel, right? Now let's take another example. So let's suppose our second example is like this. So suppose we have been provided the coordinates of a point on the straight line as, let's say, maybe 5, -5, right? That's a point on the straight line. And also we have been provided with the angle theta, meaning the angle that the straight line makes with the positive x-axis. Say suppose this is 45 degree, right? Now we have to find the equation of the straight line. In this example, they have not provided the value of the slope. Instead, they have provided the angle of inclination, right? So if we have the angle of inclination, from there we can easily calculate the value of slope. So we can say the slope is nothing but tangent of theta. And in this case it would be tangent of 45 degree, and tangent of 45 degree is actually positive 1. Alright, so we have the value of slope now. So we have calculated the value of slope, which is actually m. So m is equal to positive 1, and then rest of it is pretty easy. So we are going to use the same equation, which is y minus y sub 1 is equal to m times x minus x sub 1, and let's substitute the values of the known elements here. So it would be y minus, what is y sub 1 by the way? In our example, y sub 1 is this right here. This is our y sub 1 and this is our x sub 1. So y sub 1 is actually -5. So we have to write it like this. You know, you cannot miss the sign of the coordinate, right? You need to carry the sign as is. So that will be equal to m. What is m? M is actually positive 1 that we have just calculated. So that would be m times x minus, what is x sub 1? Well, x sub 1 is positive 5. So I'm just simply going to write positive 5 right here. Right? So from here, if we simplify a little bit, what we are going to get? We are going to get y minus negative of 5, that would be y plus 5, is equal to 1 times x minus 5, that is x minus 5. And from here, let's now bring everything to the same side. So it would be x minus y and then minus 5 and one more minus 5, all of that equal to 0. From there we can say okay, that means x minus y minus 10 is equal to 0. So that is one format, and we can also express it like this. We can say okay, if we keep x and y on the left hand side, so that would be x minus y is equal to 10. So that is another format. And also if we keep just the y on one side, so you can say y is equal to x minus 10, right? That is also another format. So all three of them are valid equations of this straight line. It's just different look and feel, but they all represent the same straight line on the Cartesian plane. I hope everything made sense so far. Thank you for watching. See you in the next video.